Hello everyone, and welcome back to my CA3 final project description on the game of BlackJack. Just before we deep into the menu, I do have a number of imports. I have the text.read, data.car, that's used for the two lower, system IO for the import-output operations. I have qualified data text IO in there as well, because some of the qualified overwrite some of the system ones if not qualified. Data.list for operation on my lists of enums and my integer lists are in there. The system environment and system random for random generation of numbers, and my file IO reads would be in there as well. The qualified data.map for my map to lower is in there as well, so that I can actually read the input without having to worry about upper or lowercase words. Okay, so in the menu, we're finally in the menu, and I have the doubles and the IO. So I have the current and the target balance passed in here. This is just so I can pass again, and it says welcome to the BlackJack with rules, play and begin. So you have to choose one of those. If you don't, you get put back into the menu with the same values. Otherwise you get to start the game putting in 5 into the game itself. We have the list of cards for the dealer, which is generated, and the 2 from the player initially, like I said before, and you've got your target balance, your current balance, and the 0 is for the current bet for the game, because when you hit a stand, I call it again, so I need to find a way of preventing it going into asking you for another bet amount for that current hand of the game. So anyway, in this, if you choose rules, I open the text file that I showed you earlier, rules.txt. In read mode, I get out all the contents, and then I put them just out to the line, and it displays your rules in detail for you to follow there, and how the game works, because each table in BlackJack does have their own rules. So this is more relevant in this case, that it shows you what's going to happen as you play the game. Map to lower the command. Like I said, this is it's all lowercase, so if they enter in a capital P or a capital A, it'll still pick that up. And then if not, it just tells you, make sure you please enter in the correct choices, you know. So what happens is, if the command is exit, then you exit the game. Otherwise you can call the menu again if they didn't write anything relevant to any of those matching cases. Otherwise, what we do when the game starts is we have a new dealer generator and a player generator, and we draw up the cards. This makes it unique every time the game starts, that the cards are going to be unique. But this is just for the first run of the game. Every other option down in the game itself will also generate these new values. Otherwise they would probably show up the same for the player and the dealer, or they probably show up repeating for the dealer and player, so every game will be the same. So you would always lose, always win, always hit a stand, so that wasn't very good. So I had to do it this way. So what we first do is we take in the bets, and if the current balance is already bigger than the target balance, then they've already played the game enough times to win with their amount. So it shows that what they got to, because they might have bet more than the amount that they needed to get to, and then we show the balance. Your target was to reach the balance, you won the game, well done. And then otherwise we go through the rest of it, which is the bet. So if the bet is 0, which is by default, then it asks them answer the bet, and it gives you your balance out of the target balance you have so far, because you just started. Enter the amount to bet on the new game, so you choose a value. This is reading as a double again. If the bet value is smaller than 1, or the bet value is bigger than your current balance, you're not allowed to bet validly that amount, because you don't have that much money and you can't bet 0. It makes no sense. So that's in there to prevent that, and you call it again if they do it the wrong way with a 0 for bet, so it'll just run again. Otherwise the bet is accepted and we start again, because once we're in this else we can't get anywhere else, because we need to go into this one, so it needs to be checked again up here. So I just call it with the bet value as double, which is obviously not going to be 0, so it carries on down. because we've already validated it will be a valid bet. What we do is we first check then after the bet is entered, because it could be already bust, but we don't want to show that till we've actually started the game. So what we do is the sum of the cards and the hand value of the dealer cards. So this is just going to give you the sum of the points of the cards. If it's bigger than 21, dealer's already bust, but we still want to show what the current game is and said dealer busted, you win. And then we start a new game again with the bet at 0. So that will actually automatically show you the increase or decrease if you won or lost of your current bet, and then ask you for another bet. That's where it'll stop, so you can see the output that you actually won and how much money you got increased. So what we do is we create new generators. This creates our unique game again, and the current balance plus whatever they have bet. So obviously they only got into this if they had a valid bet, so we add the bet on, and then we have the same target balance and we start at 0. Otherwise, if we have gone bust, then we lose, and you cannot get below 0 as the allowed bet is more than you have here. This is a check that if we take away from the bet, then we have to say you lost all your money and just let the game exit to the do you want to play again. This is the exit condition there, same as this one here. It's the only one where you can actually get out of the game, because you've obviously lost or gained all your money. Right, so what happens in that case is it just falls out, but in the other one, if that's not true, then we just generate again and we can take away the bet safely, knowing that we're not below 0. So with that done, so yes, less than 1. That was for the double, in case it had, say, entered in 39 and it halved to something 0.5. That would leave that if they had 0.5 in the bet, that we still don't let the game run, because they can't enter 0 or 1. So we don't want to have them bet half, because that would do some weird stuff to results at the end, and the game will probably never end. It would just keep getting smaller and smaller, reaching 0 but never quite reaching it, so the game would never end. So we just end it if it's below 1, because it would be a half if they entered a bet that we halved, and it was like 10.5. And they could only bet 10, and then they had 0.5. That would, because it's less than 1, will exit the game. Otherwise, if the sum's equal to 21 for the player, they get the blackjack. We're not going to let the dealer have that kind of bonus, you know. So that's written in the rules. So we get 1/5 times the bet. We show that, and we generate a new game. And what we do is we add on to the balance the bet and half of the bet. So if that was 10 and that was 5, you get 15, which is 1.5 times the bet. Target balance, set it back to 0, runs again. You get half your bet plus your bet. Yep. If the sum of cards is the same as the cards you got, obviously they've generated enough cards that the dealer won't be drawing any cards, so we can just say it's a draw that time. And all you do is just call it with the same balance, no change to the values, you know. The bet wasn't won or lost, so we just have the same balance. For dealer cards and the cards here, this is just explains how the display is shown for the cards. We'll show you that later when it's running later. Sample for the player has 2 cards, has 1 if you choose hit. So this just shows you the new cards every loop that we go around. Now, if you get to this point where nobody has automatically lost or won, we have a choice. The same command is to say hit or stand. If you choose hit, we need to play a generator again, and then we draw the new player card function from earlier. That allows us to generate a new card randomly, and then we let the new player cards equal the current player cards plus that list of 1 card, which gives the new card, and we just call the function again, but instead of the player cards we have the new player cards, because the dealer is always going to be the same, and it just goes around again. Otherwise, we check if they said stand. This runs here, but what happens here is if they didn't enter anything, it just asks them again, and it goes around the same amount, which means it'll obviously equate all the way down to the same, passing all these checks, and ask them again. But If we say stand, this is also equated the same way for the win and lose conditions. Then we need to obviously know that we haven't bust, so we need to do different checks using the point total, which gives us the total. So as we were saying, if the check is equal to you win, as you know from point total down here, we've already just checked. So we don't have to write all this into that equation. We can just say that it's equal to game draw, win or lose. Then you print out the cards and you say you are higher. This is if the you win is for us winning the game. It will show that, and then we just generate the game and we can add the bet on, because obviously they didn't get blackjack. They didn't win outright because the dealer went bust. This is just if they were higher than the dealer. Then we win. Otherwise, if it says you lose, the dealer got higher. So you say dealer was higher, you lose, show the cards. And then we check the bet again is not less than 0, so that the lose all the money came over. And then we show the target balance, and so you lost the bet. Well, you lost your bet is what this is explaining. So you take away your bet. And then in the other one it's a draw, so we just start a new game. Balance is 0 again. No, the bet is 0 again, because it's starting a new game, you always put 0, otherwise you put bet, like this one, we're restarting. And there's no change of money, no change to current balance on a draw. And you say, you drew the game, no money won or lost this time. So that kind of stops right there. And the logic with the draw earlier is that there's no way that can be equated because there's only 2 cards. But if they did, then we know the dealer is at least over 16 in value. So drawing a card in either case will probably lead to most people saying stand. So we just made it a bit more efficient by just letting the choice be removed. And it automatically would draw probably about 20 points each. Then it will obviously mean that most players will probably just stand and equate this anyway. So we just made it a bit quicker by avoiding one extra input. So that's the basic explanation of the code, but the best way is to see it running. So in the next part I'm going to show a bit of that, but while I've got a few more minutes I'll close that off and I'll show you the module, which is just BlackJack. And I tried to import it, I don't know exactly what it was that was wrong, but the way I have it laid out probably is why, but for now, yeah, it's probably just this part. So I just put all the functions that I had at the bottom in here, and I would just call them inside my other one, but I spent a good hour trying to see what was going on, and I don't know exactly what it is, but yes, that's what I have there. So in the next part I will show you how to load it into GHCI. I'm sure you can probably put it in CYGWin, SIGWin, but I don't have this on this computer and I'm not doing any command line arguments in this program, so it's not really needed. So if you can use this, that's great. It's just the same normal procedure as you'd load any normal file into it, because there's no command line arguments to put into this. See you in the next part. Thank you.